In this video, I will talk about how to create a function to plot the dataset that we downloaded from the website. So remember that in our current working directory, we have already the marketindex.mat, that's our workspace file. So we can load it first. And this is our dataset. You can see we have the date, open, high, low, close, adjusted close, and the volume for the S&P 500 stock market index. So I will show you a function. But before that, if you want to access the columns of this dataset, which is actually a table, as you can see here, and this is the number of rows and it has 7 columns. So if I want to access, let's say, the 6th column of this, I can use the following table to array. This is a built-in Matlab function. So you can just select, and you can see that it will show you this column. You can also do this and assign this to a variable. So you can see that now X is a vector of double precision numbers. Okay, so we converted the type. We selected one of the columns of our dataset, and it is converted to a vector of double numeric numbers. So let me show you a function, and let's go over this function. I'm not going to spend time to rewrite every line here. I will describe the code. So I just create a function. The name of this function is indexPlot. It takes the input of a data table, and it has a plot flag where if the user wants to create a plot, it can input 1 for the plot flag, otherwise it will not create a plot. And I'm selecting some columns from my data table. So you can see this is the adjusted close prices, this is the close prices, and the first column is the dates. And in line 5 here, I'm using another Matlab built-in function, which is the moving average. So if you input the close prices of the asset, and you can tell what's the slow and what's the fast and slow number of legs to use in calculating the moving average, it's going to create 2 lines of moving averages with respect to these 5 legs and 22 legs. Okay, and I want to plot this together just to make my plots a bit more richer. And usually the traders might use the moving averages to take a long or short position in the asset anyway. But this is just an example for us. And I'm doing some plotting here. When I plot, you can notice that the first these 2 lines here, these are just to adjust the size of my figure according to the screen size. So basically I'm using half of the height of my screen to output my figure. So these details you can search in the Matlab help files. So that's not that important for the moment, just for the aesthetics of my figure. And then you can see that I'm using my dates. Because of the moving average, we lost actually 22 days because we are calculating the average of last 22 days to start with. So I just skip those 22 days for convenience because we don't use them. And you can see that I'm plotting my close prices here. And this K, this is to give the black color. This B is for blue and R is for red color to color your figure curves. And then hold on basically means my plot is hold with the current first plot, and then the second plot will be added on top of it, and one more plot, the third plot, will be again added on the top of the same plot. And then this line 15 is basically to set the font size of my figure, the x-axis, y-axis, or the labels. And you can also input the timeline format. Okay, you can check this function in the, again, Matlab help file, and this determines the format of the display. So I will skip some details here. And basically, I'm also calculating the log returns using the adjusted clauses. So this is basically from 2 to the end, and you are dividing term by term. So this is dot division. That means every element in this vector is divided by the elements. So it is the element by element division from 1 to n minus 1. And if we take the log of this whole vector, it gives us the log returns, which is day by day, based on the adjusted close prices. And finally, this function calculates the average daily log return, the standard deviation of the daily log return, the skewness, and kurtosis of my log returns data. And it will also return to the user as the mean volatility, which is from the daily, of course, skewness and kurtosis. So you can run this function easily by inputting this data that you load. So we can actually copy paste from the function syntax easily. So you can do the following, copy paste here and change this to your data, which is market index, and let's put the flag as 1. Okay, let's put a semicolon not to print everything. And you can see it gave me the plot of the S&P 500, which we downloaded from 2010, somewhere here, all the way up to 2018 summer here. And you can also notice that we have our moving averages. And if you zoom it, you can notice that the blue line is the fast moving average, which has a smaller number of legs, and the red line moves slower because it is based on the last 22 days of the previous close prices. So that's called as the slow moving average. Okay, thank you.